Hey everybody, Mathmania here. Today we're going to be taking a look at the 1998 AP Calculus BC free response question, and that is question 6. So I have the question 6 right over here, and let's dive right in. This question has 3 parts. So starting off with the main blurb, which is a particle moves along the curve defined by this equation right over here. The x-coordinate of the particle, x of t, satisfies this equation. So this is a differential equation. I see we have dx dt for t is greater than or equal to 0. Okay, so I'm going to stop right here. I noticed that we have 3 variables we're working with. We have y, we have x, and then we have this t over here. And t is bounded between 0 and infinity, right? With an initial condition of x 0 is equal to -4. So automatically, I know from here, I can say that t is equal to 0. That has to be our t value. And I think with that, we can go ahead and solve part A. So part A says find xt in terms of t. So it's basically asking us to find an equation of x of t. And for example, that equation can look something like this one right over here. So it's just a general equation, but in order to find x of t, we need to use this section right over here. The reason I'm using this section is because this piece of information correlates y and x, and this piece of information doesn't really give us much information on t. This is the only piece of information that relates x to t. So in order to find that function xt, what we're going to do, we're actually going to integrate this right over here. So I'm going to rewrite the top as dx dt. So now I want to get everything that has a x on one side of the equal sign and everything that has a t on the other side of the equal sign. Also, I want to make sure that dx and dt, they're both in the numerator, because then only we can really take an integral, right? So I am going to shift dt to the other side, so I'm left with dx. I'm going to write that a bit lower. Dx is equal to dt over square root 2t plus 1. There we go, 2t plus 1. Now we are going to integrate both sides right over here. Now, one thing to remember is that we need to find the bounds of integration. Let's start with the right side, because I believe that the right side is pretty easy to find the bounds of, because we see that they already gave us the bounds of t. That is, t is greater than or equal to 0. So our lower bound is going to be 0. Our upper bound is going to be any t value right over here. And for the left side, we need to know what our lower and upper bounds in terms of x are. So that is where this initial condition comes in. We see that when t is equal to 0, the initial x value is -4. So I'm going to write -4 here. And the final x value is just going to be an x value. We don't know that x value, so I'm just going to write that as x. And now we have our integral set up. So I'm going to solve this integral, and hopefully we will achieve the correct x of t. Now, if you already know how to solve an integral, feel free to skip towards the end of this section and go ahead and look at the answer. But for those of you who want to walk through the integral step by step, I'm going to do that right now. First thing that I'm going to do is I'm going to take the integral of this side, since I feel that it's the easiest. That's just going to be x. -4x is equal to, in order to take the integral of this, we're going to have to do a bit of u sub. So I'm going to say let u equal to 2t plus 1. Therefore, du is equal to 2 dt. And dt is equal to 1/2 du. I just divided both sides by 2. And correspondingly, we also have to change these bounds in terms of u, or using this equation. So I'm going to say when t is equal to our lower bound, t equals 0, u is equal to, and I'm going to replace t equals 0 in there. So 2 times 0 plus 1, which is 1. When t is equal to t, which is our upper bound right over here, then that means u is equal to 2t plus 1, which is just 2t plus 1. So our bounds are going to be lower bound, bound was 1, upper bound is 2t plus 1. And we found that dt over here is equal to 1/2 du, so I'm just going to replace that for 1/2 du over square root u, because we said 2t plus 1 is equal to u. Now simplifying the left side, this is just going to be x minus 4 is equal to, I'm actually going to take the 1/2 out from over here because we can't do that, it is a constant. And I'm going to rewrite this as 2t plus 1, or 2t plus 1. And this is u to the power of negative 1/2 du, just so it's easier to take that integral. Left side becomes x plus 4, right side becomes 1/2. And now we are ready to take the integral, so I can do 2 square root u, and the bounds are the same. Left side stays the exact same. Right side, we can actually cancel these 2's. And if we plug in the bounds, we get 2t plus 1 minus square root 1, and square root 1 is just 1. And finally, our x value is going to be 2t plus 1 minus 5. Now don't stop right there, because in part A they said find x of t. And here we found x. In hindsight, they are the same exact thing. I just put x as the upper bound, but you could just put x of t as the upper bound. But just to be safe, we should just write x of t is equal to square root 2t plus 1 minus 5. And that is our final answer for part A. All right, so part B says find dy dt in terms of t. Right off the bat, I see that we don't have an equation of y in terms of t. The closest thing we have to that is this equation right here, which is y is equal to x cubed minus 3x. So we're actually going to make use of that equation right over here. And that is because if we take the derivative of both sides with respect to t, we're taking it with respect to t because the question says dy dt, not dy dx. So our right side is going to be 3x squared, right? Just taking the derivative of x cubed normally. But because we are differentiating with respect to t and not x, we're going to have a dx dt. And this method stems from the chain rule. So moving along, we have this minus 3x. Derivative of minus 3x is just minus 3. But of course, we have to multiply that by a dx dt. All right, perfect. But now it says in terms of t, but we have an x, we have dx dt. Let's try to simplify that. So I am going to take 3 dx outside of both terms. So 3 dx, we're left with x squared minus 1 right over here, x squared minus 1, yep. And I'm going to replace dx dt with what they gave me in the problem right over here, which is pretty neat. So this is going to turn to 1 over square root 2t plus 1. And I'm going to replace x with what we found over here in part A. So x is going to be square root 2t plus 1 minus 5 squared minus 1. From here, you can leave it just as that. We don't need to simplify it because at the end of the day, we did find dy dt. In terms of t, we got rid of the dx dt, we got rid of the x, so this is your final answer. All right, so on to our last part, we have find the location and speed of the particle at time t equals 4. This is basically a two-part question. We have to find location and speed. Let's first focus on finding the location. Now the location is going to be a coordinate pair, x comma y, because we have y over here and we have x over here. And to approach this problem, I'm going to find the value of x first. Now you might be asking, why are we finding x first? Wouldn't it be easier to find y because we already have the equation for y right there? And I would say, yeah, you're correct. But in order to find y, you actually need to plug in the value of x. But we don't know the value of x at time equals 4, right? So we actually have to find that value of x at time equals 4 and plug it into this equation to find the value of y at time equals 4. So in order to find the value of x at time equals 4, that is exactly what this equation is going to help us with. So I'm going to say x of 4 is equal to square root 2 times 4 plus 1 minus 5. that is equal to 3 minus 5 is equal to negative 2. So that is going to be our x value. Now, in order to find the y value, as said before, let's just plug it in right there. So our y value at t is equal to 4 is going to be negative 2 cubed minus 3 negative 2. So I'm just replacing the value of x with our value of negative 2 that we just found. And simplifying this, we get negative 8 plus 6, which is negative 2. So our location is negative 2, comma, negative 2. Now for the second part of the problem, which is speed of the particle at time equals 4. In order to find the speed, there is actually a direct formula you need to memorize, and that is this formula right over here, which is speed is equal to square root dx dt squared plus dy dt squared. So this is the formula that we're going to be using to find speed at t equals 4. So we already know dx dt, right? Dx dt is this value right over here, but we need to find it at t equals 4. So I'm going to replace t equals 4 in this dx dt. So that is exactly what we're going to do. We're going to go down here, dx dt, and we saw that was equal to 1 over square root 2t plus 1, I believe, 2t plus 1, yes. And dx dt at t equals 4, I'm just going to replace t for 4 is equal to 1 over 3. Yes, 1 over 3. So we found dx dt, and now we have to find dy dt at t is equal to 4. Lucky for us, we found dy dt in this part right over here. So we can say dy dt at t is equal to 4. This is going to be a pretty long one, which is 3 times 1 over 3. And this is going to be 3 minus 5 squared minus 1. Once again, I'm just replacing t is equal to 4 in this equation right there. And if we simplify this, that and that got canceled, and we're left with 4 minus 1, which is equal to 3. So we found dx dt and we found dy dt. Let's plug 1 and 2 into 3 right over here. So we have speed is equal to square root of 1/3 squared plus 3 squared, which is equal to 1 over 9 plus 9, square root 82 over 9. And that is going to be our final answer for part C.